Good morning, students. My name is Kranti Kumar. I am working as assistant professor in Department of ECE in BBRIT Narsapur campus. Now, in today's class, I am going to discuss subject electronic circuit analysis. From that, I am going to discuss the small signal analysis for BJT amplifier using H parameter model at low frequency. So, let us start the topic. In this small signal equivalent circuit model of BJT amplifier using H parameter model, we have seen the word H parameter. So first let me discuss about what is H parameter model. This H parameter is a two-port network. You know, if a two-port network, in this two-port network you have some voltage V1 as input, some current is flowing through I1. Due to that, if output is V2, some current is flowing, that is I2. Then using this H parameter model, you can represent V1, I2 as H11, H12, H21, H22 as I1 and V2. If you see this one, V1 is equals to H11 into I1 plus H12 into V2. And I2 is equals to H21 into I1 plus H22 into V2. Let us take this as equation 1 and this is equation 2. To calculate the H11, H12, H21, H22, once make output as a short circuit to calculate two parameters, and once make I1 equals to 0, that is nothing but input as open circuit. So first I am making output short circuit in both the equations. If you see this one, in equation 1, if output is short circuited means V2 equals to 0, then I will get V1 is equals to H11 into I1. From this I will get H11 is equals to V1 by I1. Similarly, equation 2, if you see equation 2, there if I make V2 equals to 0, if V2 equals to 0, that implies I2 is equals to H21 into I1. That implies H21 is equals to, that is H21 is equals to I2 by I1. Similarly, if I make I1 is equals to 0, that is input open circuit. I am making input open circuit in both the equations 1 and 2. So if I make equation 1, I1 is equal, if I1 is equals to 0, what happens to equation 1 if I make I1 equals to 0? V1 is equals to H12 into V2. That implies H12 is equals to V1 by V2. Similarly, here in equation 2, if I make I1 equals 0, equation 2, if I1 is equals to 0, that implies I2 is equals to, equation 2 will become I2 equals to H22 into V2. That means H22 equals to I2 by V2. If you see, we got H11, H21 and H12 and H22. Here, if you see the units of H11, V1 by I1. V1 by I1 is nothing but volts per ampere. That is nothing but it has the units of ohms. If you see this H21, I2 by I1. I2 by I1 has, this is amp, I2 is also in currents, amps, and this is also in amps. So it has no units. Similarly, H12 is V1 by V2. This is also voltage and voltage no units. If you see H22, that is equals to I2 by V2. This you will get as mhos, units as mhos. Okay. So if you see this one, H11 is equals to V1 by I1 and units as ohms, means impedance. So I am representing for our BJT analysis for BJT amplifier, we are not at all representing it as H11, H12, H21 and H22. Okay, this previously in your PEEE subject or BEEE subject, basics of electrical or electronics engineering or principles of electrical or electronics engineering, you may have represented as H11, H12, H22, H21. But in our BJT in electronic circuit analysis, in BJT amplifier H parameter model, we are going to represent it by another representation, that is H11 equals to V1 by I1 is nothing but it has the units of impedance, and V1 is input voltage, V1 is your input voltage and I1 is your input current. So I will represent it as input voltage by current, input voltage by input current. So it is nothing but input impedance. It is input impedance. Okay, H11 is input impedance. So, and similarly H21 is equals to I2 by I1. I2 is nothing but output current. I2 is output current divided by the input current. So, ratio of output current to the input current. So, it is nothing but gain. It is nothing but output by input is called gain, and it has output current by input current. It is represented as forward current gain. Forward current gain. Forward current gain. And H12 that is equals to V1 by V2, that is equals to input voltage. V1 is input voltage, V2 is output voltage. Actually, if it is output by input, then it will be called as a gain, and it is actually inverse, input voltage by output voltage. So that's why we will call it as reverse voltage gain. Similarly, H22 is equals to I2 divided by V2, that is nothing but output current divided by output voltage, that is nothing but output current by output voltage, that is output admittance. Output admittance. If you see these first letters, if you see the first letters of this one, input impedance, first letter is I, input, this is input impedance, first letter is I. So I am going to represent it as H11 as input impedance, first letter is I, so I am representing it as I, HI. Now today onwards, from this time onwards, H11 will be represented as HI in our this ECA subject, and H21 will be first letter is FF, forward current gain, small letter is F, so I am representing it as HF. Similarly, H12 is first letter is reverse voltage gain, this is HR, and H22 is output admittance, HO. Okay, if you see this one, now I am again writing it as, rewrite this V1 equals to H11 into I1, H12 into V2 in terms of HI, HF, HR and H0. That is V1 is equals to H11 into, actually it is H11 into I1 plus H12 into, if you see this one, previous H12 into V2, but H11 is previous slide, it is already represented as HI and H12 as HR. So this is HI into I1 and HR into V2. Similarly, I2 is equals to we know that I2 equals to H21 I1 plus H22 V2. But what is H21? H21 is represented as HF and H22 is HO. So I am representing it as HF into I1 and HO into V2. So this is and let us take it as 3 and 4 equations. V1 equals to HI into I1 plus HR into V2. I2 equals to HF into I1 plus H0 into V2. If you see this one, HI into I1, HI has some ohms and this is amperes. IR, so it is nothing but it is a voltage. H into I is present as a voltage, and HR is not, you don't have any units, and this has V2. This is V2. So I can in a circuit model, I can represent V1 equals to HI into I1 plus HR into V2 as a some V1 is a, you can representing it as, if V1 is a source, then it is represented by HI into I1 and it has HR into V2. HR into V2. So this, the for a current flowing through, this is I1. Similarly, if you see this one, I2 equals to HF into I1 plus H0 into V2. That is nothing but HF don't have the units and I is the amperes, and H0 into V2 is nothing but H0 is the admittance most and V2 this also get the units of current. So I2 equals to HF into I1. I am representing it as, if I2 is my current, it is divided into two parts. I2 can be divided into two parts. One as HF into I1, and one more is, it is the current H1 by H0, and the voltage across this is V2. So in this way we can draw the H parameter model. V1 equals to HI into I1 plus HR into V2, and like this. Now this is generalized one. This is in general way. But in amplifier we have CB, CE and CC amplifiers. We have seen three configurations for CB and CE and CC. So for this we have to represent this one. Okay. So how to represent that? For CB, CE and CC amplifiers. For this H parameter model, I will represent H parameter. What is H parameter? If you see this one, it is HI and HR and HF and H0. So for these things, how to represent is same. For all of these, it will be HI only. Input impedance, you will represent it as HI only. But for CB amplifier, you have to add one subscript small b, because it is a base, common base amplifier. For configuration, from base configuration, it is B, small b. For I, what it will be? If you see this one, emitter, so HIE, it will be added by the subscript suffix E, and for this one common collector, it is C. Similarly for HR, it will be, for all it will be HR only, but subscript is suffixed by small b. For common base, it is B. For common emitter, it is E. For common collector, it is C. Similarly, HF B and HF E and HF C. This one also similarly HOB, what it will be? HOE, HOE, and this one it is HOC. Okay. Now we have seen the basic H parameter model. Of CB, CE, CC, how to representations. The H parameters representations now we have seen. Now actually we are going to see the small signal equivalent circuit of BJT amplifier using H parameter. This is the equivalent circuit. But Actually, whenever you will give the signal, you will give the signal to that one. I think this you have understood. Now I am going to actually start the analysis of amplifier. Now I am taking CE amplifier here because mostly used amplifier is CE amplifier, configuration also CE. So I am taking CE amplifier here. If for CE amplifier, a transistor, if it is a CE amplifier, it is CE configuration it has, and it has some input. I am giving some input through RS and VS. I am taking some load across RL. This is my V0. I am taking V0. Okay. Now I am going to analyze CE amplifier. VS is my source input, and RS through RS I am giving in through source resistance, and I am taking output at RL, and my output is my V0. Now we have to find the parameters. We have to find the main analysis. Analysis is nothing but finding parameters. The main parameters of the any amplifier is main parameters are CE amplifier main parameters. What are the parameters in the analysis? CE amplifier analysis. We are going to see the main parameters are 4 parameters we will see for any amplifier. First one, current gain. Second one, input impedance. Third one, voltage gain. Third one is, what is that one? Voltage gain. And fourth one is output impedance. Okay. So first represent this CE amplifier as a equivalent model. Okay. So first I am going to draw the equivalent H parameter model of the CE amplifier by giving the input as VS and RS and taking the RL output the RL. So I am representing first VS, and this I have RS. Okay, already you have seen it now. You have seen it is represented by HIE. And this one will be. I think you have seen the previous one. What is that? HR into V2, and this will be HF into I1, and this will be 1 by HO, and this will be your I2, and you are taking load at RL, and this is some current, my load current IL, and this is my V0. Okay, this is my V1. Here I am applying V1. But for CE amplifier, if you see for CE, what is input and what is output? Where you will apply input? At the base. Emitter is grounded, and you will take the output at collector. So for CE amplifier, where you will apply input at base, and you will take the output at collector, and you will ground the emitter terminal here. So your output will be VCE, and input will be between VBE. And already I told you, you will use the suffix letter E here. Everywhere you have to use the suffix E because it is CE amplifier, and your output is, this is your IC, and input is IB. So nowhere I am using I1 and I2 and V1, V2. So V1 will be for CE amplifier, V1 will be VBE. V1 will be VBE. I1 will be IB. I1 will be my IB. Similarly, this V2 will be my VCE. V2 will be my VCE. And I1 will be IB. I2 will be IC and VCE. Output V2 is your VCE. Right. Now for this I am going to find current gain. It is represented by, first I am going to calculate my current gain. Current gain AI. Current gain AI. How to define current gain? Current gain is nothing but it is defined as output current. It is a ratio of output current divided by the input current. Output current divided by the input current. What is output? Where you are taking output here? Actually, you are taking output at load IL. So I am representing it as IL divided by input is my IB. IL by IB. IL by IB. That is equals to IL by IB. If you see this one at this point, at this dotted, this red mark point, if you apply KCL, what is the relation between IC and IC? What is the relation between IC and IL? It will be both are living current. So IC equals to IC plus IL equals to 0. So that is IL equals to minus IC, that is divided by IB. Now we know that IC is equals to HFE into IB plus HOE into VCE. HOE into VCE. But actually, what is VCE? VCE is equals to the current flowing. The current is IL and it is RL. VCE is the voltage across RL. So can I write it as IL into RL? IL into RL. So I am substituting that IL into RL in equation here. Let us take some equation small one. Okay, we know that VC equals to IL into RL. So I am taking it as equation 1, small one, and I am substituting my VC in this small one. Therefore, IC equals to, if you substitute VC value in this one, IC equals to HFE into IB plus HOE into, what is VCE? IL into RL. IL into RL. But we know that IL equals to minus IC. So that is, I am representing as HFE into IB plus HOE into minus of IC into RL, since IL is equals to minus IC. IL equals to minus IC. Okay. Now what happens to that one? IC is equals to HFE into IB plus, so it will become minus HOE into IC into RL. So if I take IC, if I bring this IC to this side, it will be 1 plus HOE into RL is equals to HFE into IB. So that is nothing but IC. So what happens to this one then? IC by IB equals to HFE divided by 1 plus HOE into RL. 1 plus HOE into RL. But what is my current gain? Actual current gain? But current gain is equals to what? IL by IB. Current gain is nothing but IL by IB. That is equals to what? Minus IC by IB. So therefore, what is current gain? A equals to minus IC by IB. So already we know from this one, IC by IB equals to HFE divided by 1 plus HO into RL. Therefore, what is the formula for current gain? A equals to minus HFE divided by 1 plus HOE into RL. This is the formula for current gain. You have to remember this formula. A equals to minus HFE divided by 1 plus HOE into RL. Okay. So this is current gain formula. Now I want to calculate second parameter, input impedance. Second parameter, input impedance. Second parameter, I am going to calculate my input impedance. Input impedance. It is represented by Ri. Input impedance is represented by Ri. I am representing input impedance as Ri. Okay. How to define input impedance? Input impedance. The name itself is suggesting impedance is nothing but voltage by current. Input impedance. So it will be input voltage divided by input current. So that is equal to input voltage here it is, see here, it is VBE. VBE by input, the input voltage is VBE and input current is IB. So that is equals to VBE divided by IB. Okay, IB. And from this circuit what you can understand? How can you write VBE as? VBE can be written as, if you have KCL, if you apply KVL, minus VBE, HIE equals to minus VBE plus IB into HIE plus HRE into VCE. Okay. How can I write VBE as? Minus VBE minus applying KVL to input loop. Apply KVL to input loop. That will be minus VBE plus HIE into IB plus HRE into VCE is equals to 0. If you see this one, see, start from this, V minus VBE plus HIE into IB plus HRE into VCE equals to 0. Then loop will be completed. That is what I have written. So that implies VBE equals to HIE into IB plus HRE into VCE. But actually, what do you know? What is VCE? But we know that what is VCE? Can I write it as IL into RL? Because VCE is the voltage across RL. That can be written as, if the load current is IL and the resistance is RL. Can I write VCE equals IL into RL? Yes. So that's what I am writing. VCE equals to IL into RL. IL into RL. So therefore VBE is equals to HIE into IB plus HRE into IL into RL. IL into RL. But actually, what do you know from the previous current gain definition? We know that AI is equals to what? IL divided by IB. So from that, can I write my IL as AI into IB? Can I? Yes. Therefore VB is equals to HIE into IB plus HRE into IL. What is IL? AI into IB into RL. Okay. So VB is equals to, if I take IB common from that, if I take IB common from this, what you will get? HIE plus AI into HRE into RL. Is that correct? If you see this one, IB I have to common, AI, HRE into RL, here HIE will be there. So what will become? VBE, IB, now. Therefore, VBE by IB will become HIE plus AI into HRE into RL. So what is VBE by IB? That is nothing but your input impedance. That is equals to HIE plus AI into HRE into RL. This is the formula for input impedance. This is the formula for input impedance. Okay. So as till now we have seen H parameters, H11, H12, H21, H22 in terms of amplifier representation. In our electronic circuit, how we will represent? H11 as HI and H21 as HF, H12 as HR and H22 is H0. In that way, I have done the circuit as by using this one KVLs and KCLs. I have represented as V1 equals to HI into I1 plus HR into V2, and I have drawn this one, and representations for CB, CE and CC. For C, the parameters, H parameter represent HI, HR, HF, H0, H0 will be same, H0 will be same, but it is subscript is suffixed by, for common base configuration it will be B, and for common emitter it is E, common collector it is suffix will be subscript will be suffixed by C, E and B respective configurations with the B, C, E. And in the analysis of CE amplifier, we are seeing the CE amplifier analysis. I have given some input voltage Vs and through the resistance Rs and output I'm taking it across the load RL, and output is my V0. And this one will be, so I'm for any amplifier we are going to calculate 4 parameters: current gain, input impedance, voltage gain, and output impedance. For that, I am calculating the first current gain as output current by input current. So this is the formula, minus HFE divided by 1 plus HY into RL. And similarly, we have calculated input impedance formula by using this. We got HIE plus RI equals HIE plus A into HR into RL. So this is for today's class. In next class, we will see the another 2 parameters and another CB amplifier, CC amplifier, how the formulas will be changed for CB amplifier and CC amplifier. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.